Greetings, everyone. Welcome to the stream where you get your ears blasted out, and I'm fine. Right now, we are examining the differences. We have to celebrate our failures. 118 here. Here, take an error of 10. This error of 10 minus 10. All right, now you're about to get your ears blasted out for a second, so you might want to mute the stream. Actually, before I do that, I'm just going to show off the tool I'm using to test this. This is the visualizer. A crummy visualizer tool made with a Pygame window and hopes and dreams. Hopes and dreams that I hope will never come to fruition. Let's do it. Let's do this. Such words have never been spoken. I times 10 plus 10. So if we subtract 10, weird. Ignoring the weirdness, let's just try transmitting some data and seeing how badly corrupted it gets. Actually, for giggles, let's try transmitting a bitmap. So here I have a 4x4 bitmap called 4x4.bmp. Let's see if I have a hex editor open. HXD. Basically, the plan is to splice and to cut off the bitmap header, all its image data. And why is this compressed? Sure looks like it. Let me change the color of a single bit of a single pixel and see what happens. Alright, so IDAP blah blah blah. Flash. IDAT isn't a phrase, it's a cluster of pixels. What if I make this whole thing black? Why did data get trimmed out? Save as BMP. Alright, let's try this. We're gonna save this as a format that doesn't support compression, a 16 color bitmap. That says PNG. Why is it saving here? Why is it saving here? I want raw bitmap data. FF saves it. 4. Changes the random pixel. Reopens. No random pixel changed. Changes another random pixel to the letter capital D. No, let's just try overwriting the entire image with white. Let's just try that. C0, C0, 0, 0, 0, 0, 0, 0. Boom. No, what if I just delete the file? Okay, how paint doesn't reload anything. Ah! I'll add a single pixel here. That changes to F9. That was FF. What happens if I change it back to F9 manually? What if I F9? Basically just trying to find a pointer to where this image starts, which we can do by using a distinct color like black on the first pixel of the image. And contrasting. Basically, we're looking for what's changing. 4x4O will have the pixel set differently. That we can data comparison compare E4x4 with E4x4O. This 9F changed to a 0F. This is making me think the data is stored backwards. To test that, I'm just gonna change this pixel on the exact opposite side and run the same analysis. 909F. What are all these FFs? What happens if I just replace 90% of the image with red? Let's just come on. So there should be 1, 2, 3, 4, 5. Should be 16 bytes of data. 1, 2, 3, 4, 5, 9, 10, 11, 12, 13, 14. I think this is our first byte. 7, 5 might be our first byte, and the only way to check is to change it. 999900 0099990000. What? Trademark. 1, hold on. 9999. 00. 1, 2, 6, 7, 8. What if I add a bunch of random colors? 919B. Those two weren't. Okay, this is compressed. We're just gonna try transmit. Weren't going simple enough. Simpler. Basic.bmp. Now this looks right. A large chunk of 4. What's this giant chunk? Dang it! Alright, that's it. I'm just gonna try and transmit a bitmap. We're gonna try and transmit basic.bmp at 0.05 and have our visualizer try to write the output to desktop bin. F.close. Instead of f.write data, we're gonna try f.write that. What However, we have to make this a byte. Now, I can only hope and pray this doesn't crash. Stick it right to your ears. That's it, guys. Close window. Hope for the best. That took a while to download, but it was worth it. We have our test.bin and we can see what junk we have. Na-da-da-da-da-da. Alright. We are going to try to apply the rest of the code to this. We are pulling stuff out of my butt at this point. In this case, we're just going to try and go hello world, which would be hello.txt 5. I think my period might just be a little bit too short. Alright. There's our file. It's 80 bytes and it contains 3, 2, 2, 3. But well, I mean that is exactly what it said. It got heard. This is nothing like my I feel like it works better without dividing it by 10. Both commands prepped. All systems are a go. And that's it. If only that worked. The letter H appears once, but it's not the right H. I don't know, I'm clearly not doing this right. Now that I think about it, I think we can pinpoint. I think. We're too loud. We're maxing out the microphone, of course. We're too loud. We can almost consistently check row 1 for its information. So let's try that. Row 1 would be. So basically, we need to go data 0, which is row 1. Let's just try taking this, which needs to be the peak of the amplitude phase, divided by 10. This is not going to hurt this time because we figured out that we're too loud. How do we keep it? Alright, how loud are we when we do this? Well, we just got some very interesting results back. 24, 23. If we don't divide this by 10. I'm gonna get the raw phase of the sine wave, I guess. So what if we just do f dot write data 0.2 bytes? Let's try that. That was probably gibberish data. Yep, sure was. At a 250. Is obviously a -3. There's some test data for you. Very informative. What if we try sending this very slowly? I'm pretty sure at this point our difference is going to be through like corruption and stuff, which is why we should do something about that. We have like 1600 as our rate because that's exactly what it is. This is gonna take a while. Alright, let's examine that data in a hex editor. Wow, brilliant. So freaking intuitive. I love it. What we need to do is figure out how many pixels our red channel can tell us. If only it could. N. Yeah, we'll just figure it out ourselves. N plus equals data N. Data N. String of N equals string of data N. So we can try and figure out. I think it's safe to say ln equals 0. ln equals n. At the end of this for loop, ln equals n. ln equals n. If ln and plus 20 is more than n, then we're trying to basically find a. Okay, that's even more scuffed. Frick. ln is less than n. Minus 20. I don't know. We're just trying random stuff at this point. Woo! It's weird. The system doesn't trigger though. ln is less than n minus 20, which if I recall, 50. Oh, and that's n. Why are we sending LD? What are we doing with our lives? If LD was 0, D more less than or equal to LD plus 20. Maybe this will work. Where did you come from? This should be flagging our initial position and along the sine wave. And then if D is 0 and to LD, D is more than LD. If D is 0, that means you just loop back down. D flag. So we go back down without many flags. 0 flag. NAVG is 0. WRT is true, is false. T is true. False. NavQ is WRT is if WRT NavG NavG is 0. Not before and NavD plus NavQ plus equals N. Plus equals 1. NavQ is 0. Print round NavG divided by NavQ. Oh, we divide 0 by 0, so we have to start somewhere. No. If it was 1 not equal 1, and LD does not equal 0. Yacky doodle, he's a yakking dude. in this case, what we're gonna do is we're gonna just try f.right ground nav g divided by nav q, and we're just gonna try this. Freaking interference! Dot right dot two. Wrong. What, your little baby brain can't comprehend hello world? Oh. I want you to control things right again. Better this time. Letter I makes me hopeful. This is approximately where our payload would be. And it is corrupted garbage. Then again, you have to remember a few things. First of all, we've forgotten a few steps. Actually, you have to do a bit more. First of all, we have to divide by 10. Now, why do we have to divide by 10? Well, it has to do with this stream. You multiply everything by 10 to make sure it's a frequency in the human hearing range and in the software output range. So that's exactly this. Modified visualizer.py. Yeah, I'm sorry that you keep having to endure audible pain. It's science, though. And there's clearly some data here, but we can't read it. We don't speak 0D. Clearly, there's some stuff being flagged. You know, such iconic. No, let's trim everything out and get back to the basics. We're restarting. And for now, we're just gonna average. Ah, 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 ah. Let's do this. Alright, Yep. Such awe-inspiring words. As Goku open bracket, open bracket. Aren't those so awe-inspiring? And what we're gonna do is that thing I said I had to do. which was divide by 10. Round. Round! Begin! Let's do this. Yo-yo cake. This again. At this point, we may as well just write. You know what? Forget it. What we're gonna do is freaking. How about this? F.write round D divide round D divided by 10 minus 10 dot 2 bytes. That's I'm done. Let's try this one more time. Let's see the light. And wow, an audio transcription of my feelings about this project. And there's no data. Gotta. Yeah, see, we can make sine waves just fine. I times 10 plus 10. Let's see the frequencies we're outputting at for once. No refinement, just pure music. Ow! We might be a little loud. Okay, I have permanent hearing loss now, but ignoring that. So yeah, these are our frequencies. And if we print D, we'll see a lot. And we're hopefully going to see a lot of that. That's all, folks. Because our max is 255. When we're outputting frequencies of 1020, getting a frequency back. But then what is frame? We need to investigate how this thing is creating its output. Here's the problem. We're using WF.write from. You know what I've heard? I should just use audio. No, I'm gonna turn back to this old thing that I never properly checked out. What is PyTuner? How can I PyTune? FFT utils. Dang it, right. I shouldn't have done that. Yes. All of these files in the editor. That is the guitar tuner. You know what? We're just gonna try and use this in Python 3 using py-m py2 3. Oh my god! Python 2 to 3. 2 to 3. I have Python 3 to 2 to... Yeah, let's just do that. Looks about right. Gosh. Alt S. Try PyTuner. Copy it. Paste it. Yep, that's it. Was Baz. Control A, Control C. Go back. Paste. Alright, now let's just try PyTuner. How does it work? Okay. Install PyTuner. Wait, that's not a library. Pi media. No. How's it tuning? Uh, uh, Alright, let's try this. So what is Pi Media? Pi Media Python 3. How does it use Pi Media? Huh? What is an FFT? Hmm. We're distinctly interested in this function right here. Compute frequa. Now I'm not entirely sure what sample means. Now sample rate, it would be rate. These signs is just gonna be the default one provided by this thing. Comment out sound. Control F, find this. Looks like we're implementing the recognize note function too. As long as we import FFT utils. How does it import FFT? Import FFT util. I just love when you have to use ancient code to get the job done. The problem is we're expecting a decades-old Python code isn't exactly. I don't exactly know what the audio data is expected. We'll just try and feed in our usual function. We'll just do print recognize note. So in this case, size. So that. Now I was going to print recognize note data and hope this doesn't blow up in our face. Yep, it's just got that. Now let's make sure there are no other print functions that will run at all ever again in the history of the. New challenger approaching. Where did S2040? Oh, oh, ah. Okay, let's see what FF Bullseye Windows done. We're gonna A window and window and what? And I don't exactly know what this error means. I'm not even sure. D type equals 48. Numpy dot range. What's what is going on, guys? And oh 30 30 30 30 float 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 float. It just doesn't make sense, guys. Lol. I don't know why it keeps doing this. Good. I feel like it's just that reading the bytes is the problem. What is an S2048? What is an S2048? What is an S2048? NumPy. Print mode. We're literally just trying to get the visualizer to work. What is it expecting? Our audio data. Recognize no. What is 2FFT? No. I want you to find all occurrences of that. What the is buffer? 2FFT is a buffer? Alright. We'll just go with it. Whatever. We'll try. We're trying. Trying my best. The more I see this is dependent on its stupid little functions, the more anger I get imbued within me. I was not expecting raw audio data. No. It expects. It expects. What is 2FFT defined as initially? Nothing. So we supply it with 2FFT instead. 2FFT, which I was somehow supposed to know. But ignoring the key size. Alright, please just work. Tired, as I've made clear with my several yawns. Real buffer. Now, the real buffer in this case would be stream.read chunk from data. And if this doesn't work, I'm going to lose it. Why is it trying to? Why is it trying to? What? Struck the unpack. What the heck is up? That's the more I implement, the more I use. Unpack requires a buffer of byteboards. Admin isn't stream.read chunk. Why? It's chunk, obviously. What is just print it. Oh, it's working, but it's lagging. Cancel it. Round FFT size divided by 12. IU is gonna hate me after this. There is no frequency. We're gonna carry this code over from visualizer. The reason is because it's kind of destroyed my visualizer. Lines of code of the difference between a functioning visualizer. Def itself. RTest2.py. This is the real test 2. divided by 10. How is this the real test 2? It re-implements the for loop. That's right. It has a maximum recording rate because it can't be closed in traditional ways anymore. It doesn't use Pygame. Oh, way too much Bible. Although we don't have a record length variable since I deleted it. For, dramatic purposes, but poof! There we go. Fixed. That is nuts. All nuts. All of this code is so freaking stupid. And we're just gonna delete that. Actually, no point in doing frames that append since main goal is just to extrapolate test.bin. Wait, hold on, this is just the normal visualizer. May I have the attention of a real test 2, please? Weird. All of the 16, 3, 4 buffers. 1, 2, 3, 4. Okay, this is actually perfect. Every second we get our nice minus 10. Never a negative number being output by this thing. We're gonna just try to do is f.write .2 bytes. F.close. We're gonna record 15 seconds of audio and we're gonna get like 15 bytes out of that. Are you ready? We'll see if that worked. Ooh. Very interesting data. Quite odd. If I could begin to be half of what, Val. Evaluated. I could do about anything, thing. Print evaluated. Yummy. I don't want to know what frequency that was. I do want to know. Outputting. Step 1. So in this case, we print step 1 is this. Step 1. Print 1. 1. Post evaluation. Jar of evaluated. Absolutely disastrous. Number 6. Oh my gosh, these symbols so awful. These symbols are so awful. I cannot even believe. I can't. Yeah, that's exactly what it says. Let's try this. There has to be some relationship. It's very familiar to the intro data. More so, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 bytes in this. When I said to record for 15 seconds, the first second is useless. But there has to be some common theme. What are these characters? What are these characters' relationships to the original character? 1020, 1090. So we can see the exact moment the stream starts because, well, and so this is OE, then 18, OE, OE, 1090, 1090, 100, 1120, 450, 30, 800, 0. There's some common occurrence between OE, OE, DDE 2. Subtract 2 and add hex 60. Add 96. Really, you're asking me to add 98 to the post-evaluated? Well, that didn't hurt. Alright, let's try this. Okay, that was really weird. Our input, and it's the same data, but different. So the usual, we got 49. And if we look at what Xerox 49, 73. That's the first byte. Xerox 0D, 13. Bytes go. Wait, why is it 0D when the code specifically says? Hold on, our evaluation isn't taking into account is the date. Let's just try that, but I'm pretty sure it's not gonna work. I want it to. Guys, boy, I get Hello World transmitting. So the most we got out of this was Alright, the most we got out of this was yeah. No. Oh, this is try about a guy named Dell, and he lived in the south of the Samster Path. But the sanitation board really did not prove to effective as according and had Dell moved to a city in Ohio where he lived in a tree. Andy. And he played on the company bowling team, and every single night he had a stranger and dreamers. Wow, that was great. Great performance, everyone. Ay, only at work. There has to be some common theme. But how does 208 compare to any of these values? Hey, how come it's always like 100 above what it's supposed to be? You got me! Certainly I'm not about to do that. Right? Hold up. Nope, stop it. Nope. Stop the press. Can't convert negative int. 36. If evaluated is over 200, it's over 199, then evaluated minus equals 100. Gets to be charged. Okay, we have much more interesting results. Data that sort of resembles what we're going for. That means we have 3 seconds of OE. Then we get our actual data, and it's 88, D2, 6, X40 off. Let me check. X40, X D0 minus X 60. Weird. 6C, 6C. Wait. HELL! The freaking yeah! Alright, so if we turn out these first three useless bytes, we can see our corruption, but we can see it in LL print. This. Yeah, exactly. Although for some reason we're missing HELLO, comma 38 0x38 0. That's a 24 difference. However, let's be honest, we're communicating through a microphone. What do you expect? You're gonna get corruption. A6 compared to 57. 0x A6 minus 0x57. There's 79 difference. Something tells me we're missing a few bytes. Any coincidence that the corrupted data has a negative 32? That's our 0x 0x C2 alphabet. Now this appears to be our entire alphabet. Let's see if that will parse with our alphabet. Now let's just get things set for another test. Weird, but so our alphabet did parse correctly. Now let's try an emergency scenario. While not evaluated in alphabet, HR evaluated in alphabet, evaluated minus equals 32. Let's average all the corrupted values and see what we get. Our info data set is high, ABG plus equals 0xC2, 0xC2 plus equals 0x72 plus 0x50, ABG plus equals 0x8 A6 RXL LL I think I just erased a byte, so okay, so we do need to add 88 real quick. Okay, the alignment's the same. This is the position of the L. So RX are incorrect. A6, 7, 2, 7, 8, ABG, ABG divided by the number of arrows 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 9, ABG. Weird. The average error is 108. ABG divided by 32. 3. So in theory, it might only take 3 iterations to get something valid in the alphabet. But we'll just have to see. It's weird how 108 is the exact value of the L. Like the average is spiting me. What terms the L is and alright, whatever. Let's just try this. Hold on. Okay, house information was denied. Delete test up in. Well, if test up in is gone, then you can't say it doesn't have permissions to make it. CHR are not in range. 0x1100. Why are we getting? It was literally working. But F4 is 402. Print evaluated. There. Now we figure out what's going on. Is what? Okay. Apparently number 29. Shift down. We must be missing a few characters from our alphabet. If we're shifting down into the negatives, that might explain it. Oh yeah, we shift down from 25. Hex HXD, remind me what hex 25 is again? But thought percent symbols in there. It's decimal 25. Alright. Hex 19. Yeah, 19 isn't a valid character. If evaluated is less than and 0, evaluated 0 is 0 is 20, because as it turns out, wait, hold on, why is it space in our alphabet? That's anyways, let's try this. Oh wait, hold on, we didn't do this right. Oh no, that's not good. Oh no. Well, whatever. See what our junk data is. Yummy data. Let's try that again. So that's our H of the lowercase variety. Blur Kate. So genius. If we turn on all the access, go against hello.txt. What's the difference between 38 20? Works 38 minus. That's a 24 difference. You know what? What if we just start shifting down by multiples of 8 instead? We're basically trying to clamp things into alignment around hello.txt's test, because maybe it'll work. I'm not sure. I'm sorry for the error rate. Also, a well, Donovan. Okay, why did it record? Hold on. Hold up, stop the press. Yeah, that's a lot of shifting down on that last byte. Our E is a 7A. Upside, we only have 2 missing spaces this time. But that isn't changing. Oh, this would work better if I didn't have such a crummy microphone. Oh, yeah. Close. You know what? Get it. Down by multiples of 24. Hang on. Sure of this. Goodbye, ears. gosh, I am so. HELLOR. What's my friend beard? It's P8. Like, what the heck? Why is it always 5038? What pitches is it saying? When it's giving me the P8, which is DonnyWorks 50. So we're looking for a post evaluation of 80. Post frequency 890, 899. What's odd about this is that this rounds to 900. However, something to notice: 899, 880. Our output is actually off by 20. What if, for giggles, obviously, because no way in heck would this work. What if we change that output? 1 byte, once in history, matches. Mm. It won't match, but too sleep deprived. Come on, faulty take. Nope, stop that. I wonder. That's gonna be interesting. Once in history, our 2 consistent bytes are gone. Or 7 or 6 C and 670 by a double 70 but time. Reset. Visible hex 20 at the start. Like the error seems completely random. I'm not entirely sure what to think anymore. Maybe we need to be louder, maybe we need to be quieter. Actually, there's 730 hertz looking at, like in step 1 speak. What is our 730 hertz intro? SCP-682? SCP-682? That's actually our FCT. Now, we have 1460 instead of 730, which is freaking stupid, obviously. We're looking for something that matches a lot closer for real. 2040 is two times. It sounds stupid. What if we divide step 1 by 2? What if all this error correction gobbledygook was actually for nothing? Nobody cares about shifting down. What if evaluating can be over 199? What if we've been wrong this whole time? Well, I'm going to find out. One night, I aim to do what a guy did in 3 years. Python. Pi test1.py. Okay, I remember all the parameters. Let's do this. Interesting. Next act. 7:30. Check. 20. Check. 90. 90. Check. Why is it 208 when it comes out? 1090 divided by 10 is 109, correct? Yes. Why is the post valuation value? Val 1. Val 1. I swear, if Python's decimal precision somehow messes this up, I'm going to go nuts. Alright. Alright, let's break this down. So here is a random byte. 1150. How's it 230 after evaluation? We're gonna try and have an eval 0. Alright, software, you're gonna need to explain to me. I don't know, random values here. 879.99. 204 is 1020. This. How's it that after eval 0 it's 204? Because we have to divide by 2 globally. Oh, well, there you go. We solved the problem. And all of life's problems were solved that instant. There was no need for an alphabet after all. Dude had just invented dial-up on his own. With no error detection. Hello world. Hello.txt. Oh, my hopes were high. Chapter 2. My hopes were too high. Ah. Ba-da-ba-da-ba-ba. A reevaluation of how test 1 works. Ta-da. Input byte times 10 plus 10. I times 10 plus 10. How are we decoding it? I is step 1, 10. In this case, we're basically needing to put in our own value. Let's see. Alright, so we just need to see what test 1 is using as an initial value. Alright, that's enough of that. 111 turns into 101,120 hertz frequency. Now, 11120 in the file or 1119 is evaluated to 111, which is 0.999. Oh, yeah, well, there it is. First evaluation will be 102. And yet, we've done it in the wrong order. Of course, I'm an idiot. What our val 0 really needs to be, it needs to be step 1 minus equals 10. Hopefully this works. It all makes sense. Chapter 2, byte stream. Alright, welcome to the byte stream. Alright, let's see how well that works. My eyes, they must be deceiving me. Yeah, let me test something. Let me test how crummy the audio quality is. Let's see how bad we can make this, guys. Actually, that's not bad. That's like really not bad. We need to put it at 1 byte per second. Let's make that clear. Is not ideal. Our chunk size should not be 16384. At our baud rate, that is literally longer than a second. Why don't we fix that? Too. In theory, now we should be getting 2 of everything. Or a complete error. Yeah. Now output at twice the frequency. Well, with my crummy headphones, I don't think such a higher frequency than this is possible. Hello? Hi. And indeed, it decodes perfectly in this little section of its who knows how many bytes. 2 bytes short of 16 bytes. We should be able to specify record seconds. Conclusion, it took a few libraries. Take a really long sample. I don't know, a 30-second sample, everybody. And what will it be of? Why, it'll be of the legendary. Let's make basic.bmp a little different. That's basically Spamton. Okay, that looks like turbo. But yeah, if it wasn't so tiny, if it wasn't microscopic. Yeah, that's a 250 color. 2 kilobytes. Come on, let's do the math. Make sure everything would line up. File is 1.06 kilobytes. That tells me nothing. I ain't gonna know a dang diddly squat how long I need to run this program for. Doing like an extra 10 seconds delay. My stupidity and software working. I just realized I don't have my headphones on right now, which means you're probably hearing me awfully. Doesn't matter though. Or is dying. Do is I equals open basic.bmp rb.read and f 194 5 seconds per 10. Will also take approximately 558 seconds to run against basic.bmp. Into reports. Let's just make sure this is working first. That looks working. Dang it. Wrong message. I need to send basic E. Crashed. Crashed. But I got something out of that. A mostly complete bitmap file. It is. Let's calculate how off I am. Alright, Python, help me out on this one. Find out the amount of I am 12 bytes short. So you wanna know how I'm gonna solve for that? 1, 3, 4, 5, 6, 8, 9, 10, 12. There. I padded the same size now, but find the differences. Data analysis, compare basic.bmp e:/test.bmp. You ready? First of all, on first corruption, '04 instead of 12. And this precipitates to the file where every spot where there's a 0B, there's a 0, 0. Well, actually, every spot where there's a 0, 0. Good. Replace hex values 0B with 0, 0. Replace all. Is this a valid BMP file now? No. Let's find our next difference. Actually, this FF apparently. 42A. This is the verbs. Verb did it fine. Alright, what's different? That 12 up here there was never hex. Was there ever a hex value 12 in this file? Incorrect. Class BF should have been DC. Quite a few bytes difference, but it does work with text. How can I use that? I don't know. Let me just send a little test. 64. Make it, I don't know, what 60 byte thing. Hello, everyone. DLA mode. This is cool. One. Oh. Oh. And we'll just close and test up it. Stop it. Oh, it's not in there. Alright, we're gonna convert .txt. For some reason I set it to 6 seconds. Reality 64. That worked really well. I want to Cinefile at 64 seconds now. Simple and make it a 30-second file. Right. Actually, for a 30-second file, I can write bytes, so. I'm gonna change this file. Change its paint. We successfully outputted an HTML file. Now, this 0B0B nonsense. Well, of the fact that it's kind of hard to tell the difference between. So basically, we have 2 bytes of the your home file. So if we delete these 2 bytes, I don't know, let's say open test.html. First thing, open test.html, save those 2 bytes. These are 0B. I don't know what this thing's obsession with 0B is. Bytes with it. I don't know. End up with the or myself. I wonder, test1.py is 948 bytes. And 948 by 2, take 4. That doesn't. Right. 940 divided by. I don't know how it's like 1:20 a.m. I've been live for 2 hours debugging this. I'm gonna call this done. It works enough for me to use it. Directory. Call it modem. Let's make a directory called modem project. Gonna abandon all these useless files. Send. Here we go. Our files are clearly labeled and their usages are unknown. That's all, folks. Up to the 10-minute mark. 2 hours and 10 minutes on my live stream. It's 1:20 a.m. I need to wake up by like 10 a.m. tomorrow. Night, people.